In section 1.8, we're going to solve real-world problems involving proportions. So we need to first look at our objectives. We're going to formulate a ratio in a given context, construct a proportion using ratios, solve a proportion with the correct units of measure, and identify a constant of proportionality. To succeed on this TEAS task, you will need to understand not only what ratios and proportions are, but also how to set up a proportion using ratios, solve it, and identify the rate of change, also known as the constant of proportionality. You will need to look down at the bottom of the page at your keywords. The rate of change is a rate that describes how one quantity changes in relation to another. The scale is a ratio of graphical representation to actual size, and the legend is an explanation of figures used in a chart. A proportion is a ratio in fraction form set equal to another ratio in fractional form. The numerator and denominator of each ratio are scaled up or down by the same factor. So in this example, we started out with the fraction 3/8. We scaled it up to 9/24. So basically what we did was we took the 3 times 3 and got 9, and 8 times 3 and got 24. So our scale is basically scaled up by 3. In this example, if one is 4/5 and the other one is 24/30, because 4/5 times 6/6, or 4 times 6 is 24, and then 6 times 6, or 6 times 5 is 30, our scale would be 6 in this example. To write and solve a proportion, you have to know where the legend is. If on a map it reads that 1 centimeter is equal to 20 miles and you measure 6.4 centimeters between destinations, a proportion can be used to calculate how many miles are represented by 6.4 centimeters. The way that you would do that is you put the 1 over the 20, make sure you put your units of measure. It's 1 centimeter is equal to 20 miles from the legend, and on the other side, we are given that 6.4 centimeters. So one of the things when you're solving a proportion is that whatever's on the top on the left must also be the top on the right as far as units of measure. And then we are looking for X miles. And when you're doing a proportion, you will just use cross products. So 1 centimeter times X miles is equal to 6.4 centimeters times 20 miles. And then you just do your regular multiplication. 1 times X is 1X is equal to 6.4 times 20 is 128. If it were doing algebra, we would divide by the number beside the X, which in this case is just 1. So X is 128 miles. Here is another example of basically the same thing. My scale is 1 centimeter is 50 miles. So I add 50 miles over 1 centimeter is equal to n miles over 12 centimeters. I just reversed my units of measure from the example that's in your TEAS textbook. So long as I have miles on top on both sides and centimeters on bottom on both sides, I'm still fine. Then just use cross products to solve for n. So I go 50 times 12.6 is equal to 1 times n. Do my math. So 12.6 centimeters is 630 miles. Just remember, whatever goes on top on the left is also on top on the right. Same thing on the bottom on the left. And same thing on the bottom on the right. You have to set up a proportion in this example. Once you understand how to set up a proportion, we're going to go to direct proportion and constant of proportionality. In your textbook, it says two variables are directly proportional when they increase or decrease at the same rate. In other words, they're scaled up by the same amount. This rate is called the constant of proportionality. An equation can be written as y equals kx, where k is the constant of proportionality. And if you've ever taken a graphing course where you had to know about slope-intercept form, this is an example of the constant of proportionality. And you can see the table below, direct proportional equations. Y is equal to 4 times x, where the constant of proportionality is 4. Y equals 8x, constant of proportionality is 8. X over 5 is really 1/5 x, so the constant of proportionality would be 1/5, 2/3 here. Now these are not directly proportional because they have another number at the end. Either got a plus or a minus or something else. In this particular example, the x is on the bottom, so that would be like 1 over x, so it does not follow the formula. Once you understand all this, then go out and do your practice problem. Again, I've worked out these practice problems in Canvas and posted the solution key in your Canvas handouts. Good luck on this section.